Here's an interesting one. We've got some disorder in a triphenylphosphene, and there is some disorder modeled down here. So first of all, I would look at what has been done before and look at part 1, part 2, part 2. So we can also look at the labels, so we can put on the labels the part number and show all of them. Okay, so there's part 1, part 2, part 2. So what I will suggest to do is we select part 2 and we delete everything in part 2. And then we are going to, down here, we also delete the hydrogens, kill $H, and I would go cell back. So this is the previous selection. Oh, that hasn't worked because the hydrogens have been deleted. There we go. Select those ones and say part 0 and set the occupancy to 1. So we don't model any disorder down here at the moment at all. And up here I would do the same. We go part 0. Now here we know it's going to be disordered, so I'm going to set the occupancy to 0.5, but I'm going to fix it, so it's 10.5 to fix it, the occupancy to 1/2. Then I would tidy up these carbons, so we end up with a healthily looking triphenylphosphene without dealing with the disorder at all. So now we've got the raw thing. We shouldn't have any parts anymore. That's also shown here. So there is no occupancy, is all set to 1/2 on this, 1 on this, and we have no part assignment whatsoever. I would then refine this, just gently 4 cycles, see what happens. Okay. Right, so these phenyl rings don't look too terrible. They look okay, but I'd like to have them regularized. And the way to do this is we put a constraint on, a fix 66 on this, and also a fix 66 on that, and an a fix 66 on that. We refine this now. These should all be perfectly regular phenyl rings, and there we are. So this is just for the moment. I'm not keeping this to the end. I can't actually see any much disorder going on down here, but let's deal with this later. Let's first deal with this triphenylphosphene. Control Q to switch Q peaks on. Now we have the Q peaks with no bonds, peaks with bonds and no Q peaks, and now we've got the peaks back. So what we want is another one of those triphenylphosphines on top of each other. So we're just moving this over. That's Shift and Control in the left mouse. Right, I'm hiding those Q peaks again and double click on the entire entity, and the command is mode fit -S, and then same. That also puts restraints in. Now switch the Q peaks on again. That phosphine has disappeared up here, so just cycle through. It's up the top now. And I grab it with the left mouse, and I don't press any other keys, and I just move the phosphorus up there, and then I can also twiddle the whole thing into position. So now let's just turn around. Yeah, this is not so bad. I sort of got that more or less where the peaks are. Maybe this needs to go down a little bit on this side. Okay, it doesn't have to be too accurate, but you know, the closer you get, the easier it'll be later on. Hit escape. So we've modeled this disorder, and I'm going to type refine and give it some 20 cycles so it has a chance to settle. These are the part numbers shown at the moment, and I will switch them off because we don't really need to look at that. F3 toggles there. Thanks. So that looks pretty good. What I suggest to do next, so these got affix 66 on. We don't really want them anymore because I think it's behaving reasonably well. So what we do, we type affix 0, so this takes all the affixes off, and then double click on this again and type HAdd. I think we probably want them refined as riding those hydrogens, and I think we just got anisotropic on the whole thing and type refine, and that should refine this. Quite nicely 20 cycles. Is maybe a bit overkill here, but there we go. Let's hope that the ADPs behave. If they don't, we might want to put a regu on, but I think actually this looks pretty good. We can look at part 0 and part 1, and well, maybe it's worth putting a regu on those. I'll hide those hydrogens so we don't have them in the list, and type regu on this one. Look at part 0 and part 2, and do the same here, regu. So this is maybe not required actually. I'm just showing you how you can put the regus on. refined as the hydrogens are still in the list, they're just not shown. I hit the hydrogens with Control and H. So that hides the hydrogens, but doesn't take them out of the list. Does not kill $H or anything like this. That would actually delete them. Okay, 7.44%. That's not too bad. Okay, now I'd look at the rest of the structure and I go, well, there's something going on here, but there's also hydrogens missing at the moment. Then there's this thing here, so that doesn't look right. I think this carbon and nitrogen are probably the wrong way around, assuming these are carbon and nitrogen. You can look at the electron density map. So this calculates the live map. And yeah, this is quite obvious that this is the other way round here. So here I would go name N and name C. And now let's just do refine, just 4 cycles on this one. And yeah, that looks slightly better. It's not ideal though. I agree that this is a bit strange. Yeah. What's the occupancies on this thing? They are 1, so that's fine. And it's sort of strange having... Yep, I think the jury's out here. I'm not entirely sure what's going on here. Let's deal with this order down here. So first of all, I would select all of those and type H add. So see what happens. Well, this hydrogen here, assuming this is not a double bond and therefore an aldehyde, but assuming this is actually an OH, so this has done the wrong thing. This bond looks a little bit long as well, and that's fine. So basically we need an affix, an H add 23 here. So this is how you add a specific one in OLX2, and we refine this again. And that should all behave quite well. Now let's find whether we have some sort of disorder or something going on here. Well, first of all, the biggest peak, 2.3, is actually at that phenyl group here. So that's very strange. That doesn't make much sense. So the first thing I would do, if I look for signs of twinning, info, reflection statistics, and fops, fcalc. Well, there's really no signs of twinning. There's a big outlier that's just omitted here. There's not really any signs of twinning. We could also check Platon quickly, so we click on the Platon button up here, and then wait until Platon loads up. Twin rod map is a quick one to see whether it finds any twinning, but it won't. No, okay, there's no twinning detected here. So I've got no answer about this peak at the moment. So what happens with this order here? Well, to be honest, I can't really spot any disorder here, given that the biggest peak is 2.3, and if you put the QP intensity on the on the map, so these are 0.7, 0.8, you know, the biggest is of 1.2, 1.3. So I think modeling the disorder here is probably not really justified. These peak positions, so this biggest peak here, doesn't really make any much sense in terms of distances either. So personally, I wouldn't model any disorder here, given that we have some inconsistencies or some problems with the data anyway. So one thing we can do is check whether this is an artifact or whether this is actually a real thing. We're looking at 7% in R1. So what we can do, just make this a carbon. I know it doesn't fit there. There's no way a carbon can fit there. But we're just putting it in, and I'm going to go free occu. So this is now allowed to refine freely in the occupancy, and let's see what happens and what it refines to. So it refines to, it becomes very small, it refines to only 16%, and the affect has dropped somewhat. So yeah, possibly there's something real, possibly there isn't. It's hard to say. I'm going to add these hydrogens back in, H add. Yep, I'm sorry, I don't have a suggestion about this peak. It's not due to twinning. I suspect it's not really due to the absorption as well. Okay, this looks quite healthy now though, so I think this is this way around. CN, we can look at the map again and verify that this is the case. So yeah, there is some extra spurious peaks that I cannot explain. So there is something here, there is something here. So a few things are going on that I'm not sure what it is. Anyway, the purpose of this little demo was to show how to model this triphenylphosphene, and I think that was quite easily done. And over here, I think this is not such a bad model. So next thing remains to be done is adjust the formula. So for some reason this has been set to 1.5, but that really is 1. So we hit the OK button, and sorry, up here, and that should adjust the formula according to what's on the screen. So something isn't quite right. I wonder what I've done before here. Yep, these occupancies haven't been set correctly earlier, so we need to go fix OQ1. So make sure that these are all 1. This is from the previous disorder model that was hanging over. And now just the formula. So this is all nice and integral. The Q peaks that are remaining here, they are still here, but I don't think there's anything much we can do with them. And we adjusted Z and Z prime. What's moving about? It's the UEQ of that oxygen. So something is going on. I don't know whether it's worth dealing with it though. Let's see whether it settles. It looks like it is settling down. If it does settle, I would leave it at that. Yep, it's settling nicely. One last cycle. As I said, I have no suggestion about this Q peak. It's big, it's there, it needs to be explained. I don't know what it could be, and that is probably for somebody else to sort out. Last check about the Q peaks around this area. Yep, I think there's something going on that is not to do with this disorder. I don't think there's disorder here that we can model in a meaningful way. It's tempting to call this maybe the another occurrence of this oxygen, 1.75, but I think the distances then will not work out. So if I put this on, it's 1.7. It's just too far away. Yeah, I would leave it at that. Thanks for using OLX2.